got a problem from the Oxford University Mathematics Admissions Test. This problem is from 2010. Let's get stuck in. The values of k for which the line y equals kx intersect the parabola y equals x minus 1 squared are precisely k less than or equal to 0, k bigger than or equal to minus 4, k bigger than or equal to 0, or k less than or equal to minus 4, or k between minus 4 and 0. And we're going to be solving this with my favorite method, sketching. So let's start by sketching this graph y equals x minus 1 squared. So this is just a parabola that intersects, has a double root at x equals 1. So it looks something along those lines. Okay, great. Now, what am I going to do now? I'm going to sketch this line y equals kx, or at least think about the sketch. That's obviously going to be a straight line, and it passes through the origin. And so we want this straight line to intersect the parabola. That's pretty much it. And now it's pretty clear to see if k is any positive number. So if the gradient's any positive number, even if it was really, really shallow, even if it was 0, it would intersect this parabola. So at x equals 1 there. And so that means that k being positive works. Okay, great. Now, what about k negative? So let me just redraw this diagram. We've got our parabola here. What if our gradient of our line goes negative? Well, the idea here is if the gradient is a bit shallow, so if k is, like, say, minus 0.1, the line will look like this. But if k is a very big negative number, so like very close to minus infinity or like approaching minus infinity, the gradient will look like this, something like that, and passing through the origin. And you can see that there will be an intersection. So we know that there's some negative number, k naught, such that if k is smaller than or equal to k naught, then these two graphs will intersect. So kx equals x minus 1 squared will have solutions. Now, we don't actually need to work out what that k naught is. Because this is multiple choice, we know one of these answers is correct. So we know that if k is sufficiently negative, or from this picture here, if k is at least 0, there must be an intersection. And therefore, the answer is C. Now, you might be wondering, how do I determine this minus 4?